Welcome to Colonize the Ocean, the podcast. This is the March 16th, 2026 episode. I am, of course, Brendan Traxler, your host, and the owner of Atlantis Sea Colony. I guess people know that, but in case you don't, that's kind of my whole tie-in. I'm not just a host, but I also own the company that does all this type of stuff. Anyway, today we're going to talk on a very important topic, a topic that's been in a way around for quite a while, but there's been some recent technological breakthroughs that definitely have changed the game per se, and that's how we purify water, air, etc. And we're looking at it from nanotech and how that plays into it, which is fairly new. I mean, it's been around for decades, but as far as the technology actually getting into the hands of people and stuff along those lines, it's just around the corner. It's been coming out, and we're going to show some elements where it's already been used. Of course, with a lot of this stuff, NASA has been cutting edge on all this with trying to find ways to not only purify the air in the space station, but water as well. And we also look at submarines. And so both those things we draw from for underwater habitats anyway. And as we look at Colonize the Ocean or putting underwater habitats and colonies and whatever underwater. So I want to talk real quick. Again, I try to keep these short because they are considered shorts per se, but if they go a little long, they go a little long. So one thing when we're looking at, and here's the other thing before I get into this, is this also applies greatly to like the seasteaders and floating colonies and even houseboats and yachts and stuff along those lines too. So these are elements, not maybe not the air purification, but definitely the water purification. And so what we're looking at is, the traditional filtering system that we've used in the past have been bulky. I remember back in like the 90s and stuff like that, you'd read about the astronauts, hey, they're able to drink their own pee per se. And true, they can through a huge filtration system. And it's a big device. I remember seeing pictures of it and stuff along those lines. It was the coolest thing ever, I thought. Crazy, but cool. And we've come a long way since then. Maybe it was even the 80s. I don't know. I digress. But anyway, traditionally, we had to use filters and all these different mechanisms, stuff like that. Well, with nanotech, as the name implies, it's gotten smaller, it's gotten simpler, and it's gotten more effective. And we're bringing in this newer technology of graphene, which anybody that knows anything about graphene, it's ridiculously strong, it's ridiculously robust, super light, and it has a bunch of different applications as well. And one of them goes into this filtering process. Because you can have these graphene oxide membranes, and with them, they're like super thin and super light and they're still costly right now, but they're super easy to make per se, and they don't mess up as much. They don't have to all the issues that previous filtration system had, and so they don't require as much energy to run either because of just the technology behind them. And we don't have time in these shorts to go into all the technology behind how these work, but more of, if that's something that interests you, definitely look into these graphene oxide filters that NASA's been using, to the point where they've actually got them so robust and to the point where they're able to send them out to, villages and filter the water there. It strips out almost all the impurities of it, all the minerals, all the salt, all this type of thing to make it truly drinkable water. And so they've seen that this has been groundbreaking from that standpoint, because you don't have to have these larger machines doing all this work that we used to have work in the past. Another thing that with these nanofibers and these different stuff is we've also seen they've been testing, NASA's been testing on the space station, but we've also been testing it in submarines as well. So it's got dual implications, like I mentioned at the top of the show here, and that we're seeing that it's pulling CO2 straight out of salt water. So for submarines and stuff like that, it's been a new way they've been testing getting breathable oxygen. And so again, everything we look at for these things is how does it apply to underwater habitats. So we're looking at closed loop surface systems and how do we design underwater habitats to have a system that's fully sustainable on the ocean, where we don't have to rely on the land as much. And this is just one more area. Because of this technology, we are at a place now where you could have a habitat out there stripping the CO2 out of the salt water, at the same time pulling that salt water and making a drinkable substance as well. So you're getting the two necessities of life right there from the water surrounds you. And because of the way it's designed and it works, it's a much lower energy consumer as well. So almost to a bare minimum. So you're not requiring a bunch of power, which is also a concern on underwater habitats to do. So this is really groundbreaking from the standpoint of underwater habitats, and definitely something ASC will try to implement down the road. And hopefully by the time we've actually got a habitat or two underwater, technology will be soundproof enough and have been tested well enough that we're able to over the counter purchase this stuff, put it in our habitats, and we won't need the need for umbilicals for our water, for our oxygen, etc. And they're just for backups only. And so that's really the goal in all this, is how are we finding technologies? And that's what we've been talking about so far this year, or this good last month and so, is different technologies that are out there that maybe have been out there for a little while, but they've caught up to this need that we have, and in the future of what that looks like. And so the future is bright for this because it's already proven technology. They're testing it. They're showing great results. It works. And now we just have to bring that cost down and bring it into a format that is mass producible to bring those costs down. And then we're slapping them in underwater habitats. We're slapping them in submarines. We're putting them in space stations. We're putting them in spaceships. We're doing all these things to give man water, oxygen, and a low energy consumption. And that trifecta there is the groundbreaking aspect that we want to talk about today. And I thank you that we did. As always, wrapping it up here, we always have a Patreon poll that's airing at the same time you're watching this over on patreon.com. So if you want to go over to our Patreon, patreon.com/Atlantis Sea Colony, and take that poll, it is free. Just sign up for free, take the poll, put your voice out there. And yeah, I'd love to get more voices on that. We don't have tons of people taking the poll, and that's okay. But if that's something that interests you, I would like you to go do that. That would make my heart happy. And as always, I said we want to cover last week's poll as well and get the feedback from that. So without further ado, last week on the podcast, we were talking about self-healing approaches to the habitat and different ways and different technologies out there, and so the poll was, which of these self-healing approaches gets you the most hyped for the next deep sea tech dive, or underwater habitat, or however you wanted to word it, but that's kind of what we had worded there. And one of them, if you didn't watch that podcast, you might want to go back and listen to it. They understand what some of this means. But one of them was the microcapsule tech, which is proven seawater triggered healing for holes and corrosive protection. Another one was dynamic bond polymers. There's no capsule needed, but it's inspired by like sea stars and where they're they build themselves and they regrow and stuff along those lines. It's got a really quick regeneration in the water itself, and we've seen it go faster in there. Biotricks, where it's almost like bacteria in the element, whether it's concrete or metal or whatever like that. And when a crack happens, it rebuilds. Or there's a piezo-ionic elastomers, mouthful there, that are pressure sensitive, and they're quick healing underwater as well. Well, from that poll, we had a 50-50, and it was the two middle ones, the dynamic bond polymers or the biotrick with the bacteria. And those were the two that were chosen on that. And so, yeah, so that's kind of what we get into on the Patreon. So go check it out. Go vote. Go follow us over there. I'm not asking for your money. If you would like to, support us, there are different levels you can support us on. But do that. And as always, go to the website, atlantisseacolony.com. Check out our socials on there. Follow us wherever. Keep up to date with what we're doing and the content we put out. And with that being said, I'll see you next week.